right? So you guys, right? So in this classroom, so here this is a yesterday session, right? The big data session 1, and this is document, and this is the PDF I will teach with this, and these are the installation document. So if you want to refer it, you can refer here. Okay. So when we are going to install Hadoop, right? So it will installing from here. Okay. And
Okay.
this is the original website link, right? So you can refer here also. So I pointed out, like, so you want to get all the steps, so you can do, you can see here. Okay. So
Okay.
first one installation is this is a Hadoop installation. Okay. So this all Hadoop installation. This is all Hadoop. And till here, this is a Hadoop fs-ls command. We can verify the Hadoop is installed. Then
Okay.
second installation is Hive installation. The same again, I provided a link here. I provided a link here. So this is for the Hive installation. So Hive installation, the prerequisite is Hadoop. If Hadoop is running, then only you can install Hive, because it will be using HDFS directory, and for that, if Hadoop is running, then only you can install Hive. Okay.
Okay.
So here you start Hive. Okay. I will show this step. I will run one person so everyone can follow. Once after Hive is installed, I think till here. Okay. Once this is coming, then this is a Scoop installation. So the Scoop is installation is just simply download the zip file and the extract, and then set the home path. So till here the Scoop is done. Okay, and we have to copy the MySQL connectors. They are in the lib folder. That's done. Okay, then Flume installation. So Flume installation, again, download the Flume zip file from this location, tar file, and extract the Flume and set the Flume home path and bin path. So this Flume is done. And the HBase, so HBase also, this is a directory where we can download this HBase installation, the tar file, and then extract it. And here HBase is little bit different, because other one we are keeping it in the software folder. So all installation we are keeping it in the software directory. Our home directory is a software, like home Arvind software. If your name is there, home Satya softwares, like that we will be keeping it. But
Okay.
for HBase, we are not keeping in the software, we are keeping it the user local HBase directory. Okay. So I checked it, like some problem comes like when we keep it in our home. So here this is the default installation directory, user local, right? There we keep our HBase. Okay.
Okay.
So here we will set the home path and some files we have to create, right? Like we have to HBase site already there. Just we have to add the entry, and after that we will be starting the HBase start HBase, and then after your HBase shell, you will get the HBase prompt. Okay, and the
Okay.
Spark installation, the Spark zip we download, Spark home reset, and then we will get the start of the Spark shell and PySpark. Okay, so I believe like this all installations can be
Okay.
done in one day. Okay. Okay. So so this all links also there, so you can follow the links here. So everybody can follow, and I reference purpose I give in the video. And this video I have installed in every Spark, Kafka. So Kafka, all those things we will do it later once the Hadoop component will be completed. Okay. Okay, so and today I will be starting the fundamentals, because one side we are doing the installation thing and we have to start Hadoop. Okay, and I will be starting today the like starting from the fundamentals of the big data, because we are and if everyone can join me, because okay, so I will be starting the fundamentals of the big data. Okay, so we will be seeing that what are the big data concept is there, what are the different industries are using the big data, right? And what is the definition of the big data? What are the types of big data? What are the different V's are there? Okay, what are the limitation in the existing data warehouse solutions, right? So we have like big data solutions are there. Okay, so these are the characteristics, right? And what is a Hadoop, and then Hadoop characteristics, and these are the all fundamentals. And what is a Hadoop ecosystem component? Okay, so Pig is actually nowadays nobody using; it's completely outdated. Okay, and that is the reason I'm not covering in the syllabus Pig, and even nobody is asking question on the Pig. Okay, so Pig is a ETL tool similar to the like Hive ETLs we do or Spark, right? So it's Pig is using the Pig Latin script, okay, and it's having operators, right? Different types of operator is there. So we use Pig. So Pig we can do, but I suggest, right, if something is not being asked and nobody is using in the industry, we don't need to know you. Okay. But MapReduce is still we have to learn because MapReduce concept is further used in the other Hadoop ecosystem component, right? So that is the reason the base is for other component is MapReduce. So even though we are not using as a programmatically and the project, we are not using MapReduce, okay, but still we need to know the MapReduce themselves. Okay. Okay, let's start. Okay, so we are already recording the session. So what is big data, right? So when we are talking about the big data, so big data is the data is very, very large amount of data, right? So data when we cannot handle with the traditional tools, right? What are the traditional tools are there like file system or we can say SQL databases, right? So there is a limitation of the data we can store, right? If I say in the SQL DBs, right? So in a one single machine, if I store a database data, so there is a limitation is the data is whatever the size of your hard disk, right? Of the disk capacity. So there is a vertical scalability is there. Only you can increase the disk, right? Up to the configuration of the system, right? So if the disk capacity is a 2 TB or 4 TB, right, in a one single machine, right? So you cannot go beyond that. But suppose I have to store 4 TB data or 10 TB data. So you need to have a cluster. You need to have cluster where different servers are there and they have the database installed and they should share the data across the machine, right? So if I say like NoSQL is giving horizontal scalability. Okay, I will talk about what is the horizontal scalability and vertical scalability. So horizontal scalability is when data can be shared, when data is shared across machine, shared across machines in a cluster. Okay, so here the advantage is suppose I want to store 10 TB data, okay, and I have two TB 5 machines, right? Two TBs 5 machines are there. So I can easily share the data on two TBs 5 machines. I can share the 10 TB data. But in case of SQL databases have the limitation they cannot be horizontal scalable. Like SQL databases like MySQL, Oracle, SQL Server, right? So these databases are not designed like horizontal scalable, right? Because the data is in the one machine, can be stored, cannot be shared across the machine, right? So when you are installing SQL Server, MySQL on different machines, but you cannot share the data. In one machine, you can store up to the size of the disk, right? You can store data. So here is the vertical scalability is there. Okay. So if I say Hadoop is horizontal scalable because Hadoop is following the same NoSQL database concept, right? Because it's a platform, and Hadoop is not a database. Hadoop is not like Hadoop is called a framework, and Sorry, somebody is asking something. Anyone has question? So Hadoop is a framework and which is supporting horizontal scalable capability. Okay, so Hadoop is supporting all different types of file system data, file systems, and SQL databases, no SQL databases. Okay, or any type of like streaming data, right? So every type of data it is handling. Okay, so here when I'm talking about when I say the big data, so big data is the data we cannot handle with the traditional tools. So we need some different framework we need which can handle the data. Okay, so when I say the big data, so big data definition, I say the data could be any size of the data, right? If I say the data could be a 1 GB data, 1 TB data, 1 petabyte data. So any data, right, which is the huge amount of data and which has some characteristics. Okay. So what type of characteristics are there in the big data? So I say there are the different V's are there. Okay. So one is velocity. So velocity is basically when the data is coming with a high speed in a very less time. So data is called big data. And when the data is having a volume, so definitely the velocity is high, the volume will be high proportionally, right? Because the velocity will generate the more data in a very less time. And variety is the data is coming from the different sources of the data, right? Photos, videos, audios, okay, files data, right? And sensor data. Like aeroplane is using, like flight is using the data is sensor data, right? It is generating the sensor data. It is not using, it is generating the sensor data. And that is helping to the analysis of the flight, right? From one place to another place, okay? And veracity is the characteristics like the data should be bug free, error free, right? And data is truthful, right? So if I say if the data is meaningful, then only we do the data analytics. Otherwise, if suppose I got 1 terabyte data, but data has no meaning and data is null data or missing data. So that data is no use for us, right? So when we are talking about the data, should we have these characteristics? Okay, if these characteristics are there in the data, so we call the data is a big data. Okay, is it clear this thing? Like when we are thinking about which data is called the big data. So big data is like data which is massive amount of data, and we need some some tool which can measure that data, right? If I say if 100 GB 100 GB file is there, can I use that data? Like in Windows, I can open that data in any file system, or I can process the data. It's no, nothing is there, right? We cannot do that, right? Even 10 MBs or 20 MBs file of notepad, text notepad file you cannot open, right? So the reason is the block size, the data, like I will talk about that, that will come, like what is the block, right? So data is internally stored in the form of blocks, right? So if I say if 100 GB data is there, so 100 GB data is internally stored in blocks. Okay. So if I say, so there is some measurement of the block is there. If I say in the Windows file system and Unix file system, the block is one block size is 6 KB, 6 KB. So 6 KB, you can think very, very less size. And if I say the same block size, same block in the Hadoop, right? Hadoop is the block is one block is 128 MB. So the block size is too large here. The design of the Hadoop is in such a way that the block is a 128 MB. So you will have a very less number of blocks for large amount of data. So data retrieval or data processing will be more faster. Okay. That is the reason when we think about why Windows or Unix, right, file system cannot process very, very large amount of data. The reason is the block size is very 6 KB, right? So that is very pretty small block size. Okay. So there are the many sources of the data is there, right? So we say a variety of the data, right? So if I say the what are the types of data is there, right? So in the around the world, if we look at, these are the three categories, right? So any data will be lying in these out of these three categories. So first I say structured data. Structured data is the data which is easy to measure, right? Like date, number, string. These data we can easily, it's like a fixed dimension data. The structured data is a fixed dimension data which can easily measure. Okay. So generally the structured data is in the databases are there, or in the files also having the data that is a structured data. Second one is unstructured data. Unstructured data is there is no fixed dimension. So if I say log file, text file, or images, audio, video, so we need some tool for that, right? We need some audio processing API, image processing API. Like we need some processing APIs, we need it. Okay. So that type of data is unstructured data. Third category is semi-structured data. So semi-structured data, we say the characteristics of the both unstructured and structured data comes in semi-structured, like files. So CSV file, I say JSON file, CSV file, email. So email having attachment is a image and the body is a text, right? So that is a one combination. And the XML, CSV file, they are file itself is unstructured, but contained in the XML CSV is a that file content is structure. Okay, so that is a semi-structured data. So these are the three type of categories of the data around the world. Okay, so we have those categories of the data is there. So what are the industries are using, right? This is pretty old figures. Okay, so don't think about this because this is old slides. But nowadays, if I say healthcare or insurance, banking, every industries are using like data analytics, because data analytics they using on the huge amount of data, especially the social media, right? So they uploading pictures, videos, audios. Okay, and like Facebook is doing a lot of analytics on that. Okay, on top of that. Okay. So these are the use cases things. Okay. So when we talk about what are the limitations were there, right, in the data warehousing solution. So first thing is like we cannot handle the unstructured data, right? So if I'm RDMS was a solution for the unstructured data, right? If I store audio, video, or text file, I store in the RDMS database, but I need to write a SQL code, very complex SQL code I have to write. I have to use binary large object. If you heard about, there is a blob and flop field is there in the RDMS. RDMS, there is the blob. These are the data types are there. There are the different data types we use, right? Varchar, int, sort, double. So blob and flop, okay, binary large object and character large object. So we use this for storing the image, audio, video. But you know, right, when we are writing data, it's a byte array form, the data is stored, right? So binary data, it is called the binary, and binary we need to store in the RDMS, we need to use byte array format, right? We have to store. So we need to write a complex SQL code. It is not easy to handle. But the same thing, if I'm trying to write the data in the NoSQL, it will be easy to write because there is like just simply dump the data, right? So it's retrieval and writing the data is much easier. Okay. So another one is a vertical scalability. I already talked about that. So SQL database is vertically scalable, right? So there is no horizontal scalability. And for big data, we really need the horizontal scalability because our data size is growing every day and we have to do analytics, right? So our solution should be scalable, horizontal scalable. Okay. And cost comes, right, when we are talking about we want to find a solution, right, which should be more scalable and like who will manage this infrastructure things, right? So we need some open source tool, right? So Hadoop is the open source tool, and we need to install Hadoop on all our machines, right, in the cluster, and we can provide the solution which is a cost effective. Okay. So when we talk about um, like process of the data, so this is there in the Hadoop, right? It can process all types of data. It can store and process massive amount of data. Cost, because it's economic, right? Because it's a open source tool, right? So the infrastructure cost is very development cost is very less. Okay, and speed of processing, because it's supporting the distributed computing. Okay, like you are storing the data, right? So you are not worry about how the data will be stored. That will be basically decided by the Hadoop, right? How it will store internally, and how it will be processed parallelly. So there is a MapReduce framework, right? So MapReduce framework is provide a parallel processing. Okay, parallel computing it's providing. So the speed of processing is parallel. There is a parallelism is there. Okay. So far it is clear, right? What is the background of big data concept? What are the different V's and horizontal, vertical scalability? Is it clear so far?
Yes, Arvind.
Okay. So now if we talk about Hadoop, right? So people are saying like Hadoop is outdated, right? I will say like Hadoop has two tools. Like Hadoop itself is not only Hadoop. Hadoop is having SDFS and MapReduce. Okay. So MapReduce is outdated because MapReduce we have to write a huge number of lines of code, right? And this code we have to write in Java. So the next generation is a Spark, right? So Spark is a faster processing of the data as compared to MapReduce. So Spark has replaced MapReduce. Okay. And Spark has given, right, the advantage, right? If you don't have the data dependency, very large amount of data is not there. So you can process the data without Hadoop also, without SDFS. Okay. But if I say my data is really huge data, okay, and I want to process data with the Spark, so you need to use the SDFS for that. So SDFS is a Hadoop distributed file system, okay, and this is the file system on top of Unix or Windows or anywhere where you are installing the Hadoop. So on top of the Unix file system, we are having a Hadoop file system. And Hadoop file system, I talked about the block size. So that is this capability, right? This block size is configurable. Even you can increase this block size and you can read huge amount of data faster, okay? And parallelism is there. So storage part will never go away because that is providing analytics like storing, as well as like when you want to use, like Spark can use the data to read from the Hadoop file system. Okay. So when I say like Hadoop is a distributed processing engine, right? Like basically it has the two core component. So one is SDFS, another one is a MapReduce. Okay. So how Hadoop came in picture, right? So if I see the back history, so Hadoop is there is a one guy dog cutting. Okay. So who invented the Hadoop, right? Framework, right? In 2004. Okay. 2004. So basically he was inspired from the Google, right? Google initially gave the base paper, right? Google has given two base paper. Okay. One is Google MapReduce. Okay. Google MapReduce and um, Google MapReduce and Google HDFS or something. So Google file system. Okay. So initially they started work in 2000 year. Okay. But there was nothing progress. So this guy dog cutting started work on the same paper, right? And then he has given the Hadoop framework and how this Hadoop symbol, right? Like basically when he saw his kid, right, to playing with the small toy elephant, so he gave that the icon symbol, right, to the Hadoop, right? This toy elephant, a small toy elephant. So in 2004, he started work, like he given the initial release version, and Hadoop like point X version started, and then 1.x came. So initially point X version start, then after 1.x came, then 2.x, and now the release is going on 3.x. Okay, so 3.3, 3.5, like this releases are coming. And this guy is now the CEO of the Cloudera. So Cloudera is a distribution. So there is a Hadoop is a vanilla Hadoop. Vanilla Hadoop is a original Hadoop, right? Which is Apache and like it is the Apache community, right? Apache community Hadoop, right? That is called the vanilla Hadoop. But other distributions are there in the market, right? So there is a Cloudera, okay, and earlier Hortonworks was there, but now Cloudera and Hortonworks both are merged, and now both are one single entity, okay, Hortonworks. Okay, and other vendors are there, like IBM is having Bigdata InfoSphere, Bigdata InfoSphere. Okay, these are the other vendors, but nowadays in the market, if I talk about as an on-premises cloud distribution, right? So Cloudera CDP is used. Mostly companies is using the Cloudera CDP, and they are taking the support of the CDP. So they have cluster of 20 node, 10 node, 50 node, and they are using on-premises cluster. Okay, and now Cloudera has given the cloud version also. They are using internally AWS, but they have provided the cloud version as well, because on premises the limitation is like we cannot share the data globally, right? And suppose our vendors or our like stakeholders are on the cloud and they want to see our analytics, right? So they need a cloud. So instead of going directly on AWS, so Cloudera has provided cloud version of CDP. So CDP cloud version they provided. Okay. But this one is mostly companies are using, they are migrating from the on-premises Cloudera CDP to the cloud CDP. Okay. So they are moving. So IBM is there and Azure is having Azure SD Insight. SD Insight. If this one you will see when you will be having Azure. So Azure is using SD Insight, like for the Hadoop distribution. So they are providing a ready-made distribution, right? You will be having everything installed over there. So you don't need to install anything, you're on, okay? And what we are learning, we are installing the Ubuntu on VirtualBox. And on top of that, we are installing every tool and Hadoop, Spark, everything, and do practice on the our local environment. Okay, that is a single node cluster. Okay, so single node cluster is where in single machine, you have all the Hadoop services. Okay, I will talk about what are the all Hadoop services are there, right? Like storage service or processing service, right? Name node, data node, okay? Resource manager, node manager, okay? So when I come to the fundamental of the Hadoop, right? So this all I discussed, right? The Google file system and initially, right? These white papers are published. So what are the key features of the Hadoop, right? Hadoop is having the simple architecture, okay? Scalability, it's a horizontal scalable, right? The data is scalable, right? Because we can add as many as number of node or we can remove the node, okay? We can do the configuration for that. Highly available, right? If I need to, like fault tolerance I'm providing. So fault tolerance is like if my one data node is down, so other data node has the replica of the data. So I can provide the high availability by using the node availability. Okay, so that is the way we can provide the high availability by fault tolerance. So fault tolerance is like when one node down, so another data node has the same replica copy. So we can provide low cost because it's using the commodity hardware. So what is the meaning of commodity hardware? The commodity hardware is like a cheap hardware. So Hadoop says you just keep the high configuration for master node, that is a name node, okay? But other data node, you can keep it commodity hardware, very cheap hardware. So we don't need to worry about if any data node is down. So we have the another data node has the same replica, right? Copy of the data. So we are saving our cost, right? We don't need to make it all the data node machine very highly configurable machine. Only name node machine, which is having your metadata of your data nodes of your cluster. Okay, so that is the reason the cost will be low, right? Okay, and speed, right? Because we are faster processing data, right, using a distributed environment. So that is the reason speed is faster, and parallel processing model is there. We can process the data in the how many nodes are there, your data will be processed parallelly in the number of nodes, right? So that as many as number of data nodes are there, right? So your data will be processed faster, right? And allow the data analysis without first model cleans and loaded. Okay, so these are the key features of the Hadoop, and these are the core characteristics. So reliability is there, quite fault tolerance, economical because it's a cost effective, and scalable. It's having a horizontal scalability. We can add or remove the nodes in the cluster, and flexibility is it can process any type of data, right? Unstructured data, semi-structured data, structured, unstructured data. So flexibility is there. So that is the reason it is called flexible. Okay. So there are the two core component in Hadoop, right? HDFS and MapReduce. So HDFS is used for the storage and MapReduce is for the processing component. MapReduce is the processing component. Okay. So when we talk about Hadoop, is not a single only one tool. Hadoop is an ecosystem, entire Hadoop. Okay. Because HDFS is a one core component and MapReduce is another core component of Hadoop. But when I say Hadoop ecosystem, so Hadoop ecosystem has multiple different tools for the different purpose. So when I say HDFS is a core component, that is Hadoop distributed file system. On top of that, a one processing component MapReduce, and the Hadoop 2.x and 3.x has given yarn. So yarn is, so MapReduce worked earlier in Hadoop 1.x only assigning the task to the task tracker and job tracker, like that terminology was there, but resource management was not there. Okay, but Hadoop 2.x and 3.x that came with the yarn architecture. Okay, I will talk about what is the yarn architecture. So yarn architecture is a right resource management, right? So whenever the resources like jobs are there, right, and different jobs are in the running in the queue, right? So how the resource will be allocated to the jobs in the queue, right? And how queue will be maintained. So those things will be come under the resource management. And there is a need of data import and export in the Hadoop, right? So one way is like Scoop is a one tool that is bringing the structured data, right? SQL database data you can bring into the Hadoop file system. So import and export tool means data can be imported or data can be exported from the RDMS to the Hadoop file system. Okay. For semi-structured or unstructured data, we have Flume. So Flume is also doing the same job, import and export, but it is for structured, unstructured, and semi-structured data, like image file, audio file, you want to copy, right, from the local to Hadoop file system. Okay, even we have the commands are there, Hadoop commands are there to do copy command and put local copy from local put command. So we can do that. But Flume is another way of streaming way. This is a streaming way, like real-time processing data, right? We can move into the Hadoop file system by using the Flume. But for structured data, we will use the Scoop. Okay. The other ecosystem, like Hive is a SQL data warehouse tool. Like when we want to use a SQL queries, right? The database is SQL create tables, or we want to do the data manipulation, right? Using the SQL. So we can use the Hive as a data warehouse tool. Another one is the HBase. HBase is a NoSQL database of Hadoop. Okay. Hadoop ecosystem, not Hadoop, Hadoop ecosystem. So HBase is a column family NoSQL database. So column family databases is the NoSQL database category. Okay, there are different types of categories of the NoSQL databases are there, like document oriented databases are there, like Mongo is there, key value pair is there, Cassandra is the key value pair, column family database is there in NoSQL, that is the HBase. Okay, and the graph database are there, that is the New4j is there. So there are different categories because all SQL databases are same categories, right? Because SQL databases are using ACID property. Like SQL databases are using ACID, atomicity, consistency, isolation, and durability. But when I say the NoSQL database, so they follow the CAP forum. So at least two properties they should have, then we call NoSQL. So one property is consistency, availability, and partition tolerance. Okay, because it is, I told already, like NoSQL databases are like a horizontal scalable. So these properties, consistency, availability, high availability should be there, and partition tolerance. So data is shared across the partitions, right? Okay, in a cluster, right? So partition tolerance. So any one of two properties like these, any two properties are followed by any NoSQL, okay, then that database is called NoSQL, okay. But there are the categories of the NoSQL, okay. So NoSQL different categories are there, like document oriented NoSQL database, okay. So that is Mongo is there. Okay. I will talk about that, okay. So here I was talking about what is HBase. HBase is the Hadoop ecosystem NoSQL database. Other processing framework is there, Graph is there, but we are not using. Spark is the main extension of the MapReduce. Okay, so MapReduce is Java-based framework, and all the Hadoop ecosystem component is based on the MapReduce architecture. Okay, so MapReduce is a batch processing framework. Okay, it is not supporting the real-time data. It is processing a historical data. The data is in the history, right? I say like 10 years history data. I want to do analytics. So that kind of processing is called the batch processing. So MapReduce is a very good fit. And most of the times, like when we want to process unstructured data, like some image processing API I want to use, so I can use, or data conversion I can do one format to another format. So MapReduce is good. Okay, because here we are writing custom Java code. So when you're writing a Java code, right? So we can write any Java logic, we can write any processing logic we can write. Okay, and Spark is like why we go for the Spark, because Spark is giving a faster processing, and whatever code we write 200 lines of code in the word count for a word count program in MapReduce. So Spark we can write in the 3 lines of code. So that's like a libraries, because Spark is providing inbuilt libraries for the transformations. So it is making it productivity much better than the MapReduce. But Spark has the other advantages. It's an in-memory computing processing engine, right? So it's providing the data processing is much faster than the MapReduce. And Spark is used for real-time processing as well, because the real-time data, when it is coming, it is streaming data, so it can be processed by the Spark. So Spark has that capability. So Spark has different modules. So mainly the Spark modules we will go through, that is Spark Core, Spark SQL, Spark Stream. So 2 more modules also there, but that is not our purpose. Like machine learning, ML Live is there, and one is a Spark Graph. So these two are rarely used, because when we are talking about the Spark in the data engineering, we are concentrating on these three. Okay. So core is the base, right? Where is the core libraries are there, transformation action. But on top of the core, we use SQL and streaming. So SQL, you can say it is the batch processing. Okay. Because Spark is not only real time, it is both, right? Batch and when I talk about real time, I will use the streaming, Spark streaming model. So here is a Kafka integration will come, and the socket connection, real-time data by Twitter data I'm getting. So all those type of data processing I'm doing in the streaming. Okay. Like so far is clear, right? All this.
Yes, actually, I had a question. Could I ask a question?
Yes, yes, sure.
Could you go quickly back to your Node++?
Okay. Oh, notepad.
Uh,
Okay.
yeah. So I had a question for where line 1920 is. So between the vanilla Hadoop and Cloudera Hortonworks. My question was between the two components for Hadoop, which is like parallel processing, doing MapReduce, and then the other component, which is the storage. When a company wants to go to use Cloudera and take all the services from on-premise to cloud, does Hortonworks or CDP, does it also, is that the method where they get like basically for the fee that they pay, do they also get the machines that do the parallel processing on cloud, so they don't have to have it physically there anymore?
The architecture is same. Nothing changed in the architecture. Okay, whatever architecture they have, like all the like whatever you see, like in AWS or Azure, these clouds also providing the Hadoop infrastructure by their managed services, paid services, right? So
Right.
same what Cloudera, because Cloudera found a limitation in their on-premises. The problem is like when people were moving in the cloud, so they are leaving their cloud era, right? They are saying why we go for your cloud era, right? Because you don't have a cloud version. Then cloud era
Right.
realized why they, because they cannot find their own cloud, because cloud is not easy to develop, right? Like AWS, GCP, are the big companies. So cloud era already cloud is in the market. Why they put their effort to develop their own cloud? So they thought they will use the proprietary cloud, okay, but they will move their on-premises infrastructure to the cloud version, okay. So internally they are managing everything storage S3 they are using, okay, but
Right.
as the interface they are giving on top of the S3, they are giving the Hadoop file system. If you have seen in the AWS EMR, so AWS EMR, how many file systems are there? Okay, so one is, okay, one I say S3, that is out of the box, right? EMR, because S3 is the general file system, right? As a storage. But EMR
Right.
is having one EMR file system also there. Okay. So
Mhm.
EMR file system is there, and on top of that, Hadoop file system is there, because Hadoop file system they have to definitely give. Otherwise, the Hadoop capabilities will not be utilized, right? Hadoop tools cannot be used, because suppose I say
Yeah.
I want to write the data Hive in the Hadoop file system, because internally Hive data is stored in the Hadoop file system, right?
Right.
So
Yeah.
main thing, like here is the EMR file system is there, that is the proprietary of EMR, okay? But Cloudera use S3 as a internal, okay, as a cloud storage, but
Yeah.
top of that, they have given Hadoop file system. So when
Okay.
I'm doing
Okay.
the queries, right, in my Cloudera one, so I'm doing queries like this: Hadoop fs minus ls and S3 bucket. I'm giving S3 colon slash slash bucket path like this.
Okay. Okay.
Okay.
I see. Because you
Okay.
said how Cloudera is like the same developer, right, as the person that made Hadoop.
Yeah,
So
yeah,
I was
same. Like they have like see, Docketing has now CEO, and basically the Cloudera become like the leader, right, in the on-premises, and now they have moved to the cloud version also. Okay, on the
okay.
on-premises one. So the
Yeah.
advantage is like here they are providing each and every tool is infrastructure is a ready-made, right? We don't need to set up anything. Just we install the Cloudera machine, right, and
Yeah.
every node, and then you can communicate the entire cluster, okay. But when we are
Okay.
talking about our own for practice purpose, right, when I'm going for the right, so there you will not get anything. Everything you have to do manually, and you have to set up. And whenever you are logging in your Ubuntu system, right, so every time you have to start the service manually. Here whenever you just enter in the edge node, so your all the services are ready, because no need to stop, because there is a separate Cloudera manager is there, that is all services monitoring is doing, right, which
Okay.
node has which service is running, which is down. It is all monitoring by the separate monitoring services there, Cloudera manager. But in this
Right.
case, our case, like when we go for Ubuntu, so Ubuntu everything installed ourselves, right, we are installing. So we can check through JPS command, we can check like what is running, what is not running on our local PC. So but we
Yeah.
need to start everything manually. Suppose I want to work on the HBase, so I have to start the command HBase shell, okay, HBase space. When I want to start the Spark, I need to write a PySpark command. When I want to start the Hadoop, start hyphen all dot sh. When I want to start Hive, I have to type Hive. So when I have to start the services, right, manually, I have to start, then only I can work on that.
Right.
So that's a difference here, because it's a manual installation, and that's a ready-made installation, right? Okay. So
Okay.
this part is very easy. If I give you setup of the CDH, right? CDP is a paid version, but CDH we can get it. Even CDP you can get for trial version, like 60-day trial they kept it. Okay. But if
Yeah.
you find CDH, right, that is the older version of the Cloudera. So you can get CDH, but all the Spark Hadoop implementation is very pretty old version, like 1.6 Spark is there. Hadoop is the 2.6 version is there. So you will not get the benefit of our latest version of the Hadoop component. Okay, you will not get
Okay.
it. Okay. But
Okay.
you can do there, but you have to upgrade it. So you have to use some parcel are there, some packages you have to upgrade. So you have to find some commands how to upgrade, and then each and every service you have to upgrade, right? Hive, Scoop, everything you have to do, right? So
Okay, I
because
see.
that is compatible to the older version, right? Like Spark is 1.6. So Hadoop is
Okay.
according to that version is there. So when you are
Mm-hmm.
upgrading Hadoop is Spark also you have to upgrade, right? Okay.
Yeah. Okay.
So that environment you will become familiar very easily if you just log in on your Edge node, and then you can cloud like you can easily work, because the components are same, like how to, we have to understand the how to work on these, right? Like how to learn Hive, and how to work on the Hive, how to work on the PySpark, how to work on HBase, how to work on Kafka, right? So the
Right.
way of uh, running the job applications, that will be same, either you run in the Cloudera or you run in the your Ubuntu. Okay, but
Uh-huh.
here is the one added advantage that you will not get over there, that is installation part, because you will not learn anytime installation there, right? Because everything is pre-installed. But here you are learning installed version, and this is your on local machine. So it's like a, if I say Cloudera minimum like the 4 GB to 6 GB RAM is mandatory. Like without that,
Mm-hmm.
otherwise Cloudera will not be much faster. But in Hadoop, Ubuntu you are using, so even 2 GB RAM, 4 GB RAM is good enough, because Ubuntu
Okay.
is operating system like that will not be much RAM, like a RAM or RAM expensive. Okay.
Okay.
Any other question? Anyone? Yeah, everyone can ask any question. See, I want like a interactive. If you are not asking, so I will not come to know, right? What is the doubt and questions you guys have, right? These are all fundamental.
Any message in red color?
Hi, Arvind. Yeah, this is Mohan.
Now,
Just a minute. I connected on.
Yes, Mon,
I
you
have
ask.
a question. I have a question about index processing. Hadoop uses index processing, right?
Which processing?
Sorry.
Yeah, what you
Mm.
asking? Hadoop is
Hadoop process index processing, right?
batch processing, right?
Sorry.
No, I didn't understand your term, right? What
I,
you're saying?
I think it said index processing.
Oh,
No.
index.
In disk. I said in disk. I
No,
mean, not in
in this. Okay,
in
okay.
disk. I mean, will it cover? Yeah, in disk. I mean,
This one
uh,
you're saying in this, right?
yeah,
Okay.
yeah. For
In
the, I
this
mean,
means, yeah,
yeah.
I understood your term. In this means like you are saying batch processing, and it is not storing data further processing in the memory, right? So
Yeah.
every time it write the data in the disk, and again further read the data from the disk. That is the reason when we are
Yeah.
talking about the map reduce, because this terms is used for map reduce. Okay, like map reduce is processing is the batch processing only. Okay, and
Okay.
this is slower than the Spark. Why? Because
Yeah.
when you are processing some data, so when your output is coming, like some intermediate output data, so you are not keeping it memory for further processing. You have to write in the disk. Okay, the job will write in the disk. Again, it will read from the disk. So further processing, it is reading from disk. Okay, that is the reason it is taking more time for processing the data, more time to processing data. So that is the one big reason, right? When you can say, right, anyone ask you what is the difference between the map reduce and Spark. Okay, so we say when I say Spark is 100 times faster. You heard about this lot many places, like 100 times faster in memory, 100 times faster in memory, and 10 times faster in the disk, 10 times faster in disk. So if you compare this part, you can compare with the MapReduce, because 100 times faster memory, because this type of thing is not there in the MapReduce. But when I compare in disk processing, right? So this thing is a batch processing, but still here Spark is 10 times faster. Okay. So Spark is having because of the memory configuration, because it's final data, it will definitely store in the disk only, right? Because memory storage is not a permanent, right? Okay, so memory is used only for till the processing of the data. Once the process is done, and you have to store the data in a persistent storage, like either files, SQL, NoSQL, any databases, right? You have to or send the data to other target system, right? Okay, so Hadoop is using in disk, right? Means batch processing and disk-based processing, right? There is no in-memory computing processing concept is not there in the MapReduce. Yeah, that is the thing you were asking.
Yeah, it's kind of question. And will it be the same in remaining Hadoop? I mean Hadoop services. I'm not
Which
sure about it. I mean,
services like Hive.
like a HBase or a Hive or
Yeah,
anything
yeah.
like that.
See, I have to start one by one. Okay, Abhi, still I'm just covering very higher level, right? Whatever is coming. Okay, so we
Okay,
will
okay, got
start
it.
from the SDFS first because we have to learn first SDFS. Then we will go to the MapReduce, and then we will go one by one: Hive, Scoop, HBase, okay, Flume. And once
Okay.
we will cover this all six, right? Even though
Mhm.
UG is there also, okay. But
Yeah,
nowadays,
but yeah, it's expired, right?
yeah. So UG is like instead of that UG, like people are using Airflow. So I'm telling you some of the tool. If I talk about Hadoop ecosystem, there are the 10 components are there, but we are not going to do everything and we are not using all, right? So I will tell the basic concept of UG. Like if anybody asks just general knowledge, right, or your conceptual knowledge about the UG, at least you can talk about theoretically and you can say, okay.
Okay.
But yeah, but these are the main components. This is the like Hadoop ecosystem. My target is all these, right? So one is a NoSQL database, one is a SQL data warehouse tool, Scoop is an ingestion tool, Flume is an ingestion tool, and MapReduce is a processing tool, and Hadoop file system is a
Storage.
tool. Okay. Okay. Any other question? I will cover. See, I will cover and practical will be there, right? Even like this MapReduce practical, high scoop, right? Without practical, you will not see how internally it works, right? Right. So only theoretically will just help definitions, right? You can cover definition, but when we are learning practically, right, how importing is happening, right? What are the commands are there, right?
Mhm.
So I will talk.
The question is about, uh, let, let me tell you clearly. The question is about what industry is using Hadoop right now.
What industry is using in Hadoop?
Yeah. Is
So
it I mean,
still
is
is
it
using, I will say, like, see, I told Hadoop is not completely removed, right? I told MapReduce part is removed, but still SDFS is there, right? I talked about,
yeah.
right, in the EMR or other cloud version also, they are giving a Hadoop file system, right? So
Mhm.
MapReduce is, but if I say one SQL data warehouse tool, Hive still is used. Scoop is, see, Spark is can do whatever can Scoop can do because Spark is a complete ETL. So there is an ingestion of the data, okay?
Yeah.
Ingestion of the data, transformation of the data, and loading the data to the target.
Yeah,
Loading
we
target.
can mount from various
So
data sources.
if you see here, this ingestion is nothing but the same Scoop is doing. But Scoop is just doing ingestion. Scoop is not processing anything. Scoop just reading data from the SQL database and write the data to the Hadoop file system or directly write into the Hive table. But if I talk about Spark is doing the same job, right? I can do with the reading the data from the SQL database and write to the Hadoop file system with the Spark. But you know, right, Spark, we need to write a code and we have a setup, right? And that write a job and that job we have to run. But Scoop is a one single import command. If I just need to read and write data, so why I write a Spark code? Simply, I can write a one Scoop import command and I provide a source database like my SQL database, okay, like Oracle or MySQL, okay,
Mhm.
and I will define here the target directory of my Hadoop file system target directory.
Okay.
So if I say SDFS directory here, so I will single import command I will do. If I say I have to read one table and write the data as a file in Hadoop file system, who can write the faster code? Spark will be faster or Scoop? Right, writing code, if I say just I will write in a 15 second, I will run command and my data will be there in Hadoop files. If I'm going to write the same thing with the Spark, but still if I say, then why we are going to Spark, right? But Spark, I'm saying the transformation things will not be provided by the Scoop. Suppose I say, I have to read a file, I have to do various transformations, right? And then I have to write the data to Hadoop files. Then I will not go for the Scoop, right? Because Scoop will not solve my purpose. Scoop will just bring the data in Hadoop file system. Then I have to use some Hive to read data and again do the transformation. So two layers are there, Scoop and then Hive. But here, Spark will do the job for these two, right? Spark will read the data from the SQL DBs, transform the data, and write the data to the Hive. Okay. So, like everything having its own significance, right? If I say I want to write some solution like which can be job, and every day the job is running, I can do the same job with the Scoop and same I can do with the Spark, right? But here I will not get the advantage of the transformation. Advantage I will not get. Okay.
Okay. So, yeah, thank you.
Okay. So we have to learn each and so see if I say we cannot know what will be used in the project. Maybe in the project you are going, you won't get anything. Okay. Yeah, you are getting like you are processing the data in the some cloud EMR. You are using like you are processing the data from S3 to S3. You are using Glue job. So you are not getting the Hadoop environment. Okay. But some places like you are working in the Hadoop based environment, they are using Hive, or sometimes they are using Scoop, sometimes they are using HBase. So they are using. So we don't know about the project, right? What they will be using. So some projects like depend on the data where they want to keep it, right? They want to keep it data in the Hadoop file system, or they want to keep it data in the cloud storage they want to use. Okay. So that depends on the project to project. Okay.
Okay.
Okay, so next thing we have to do the installation thing. Okay, so we can do quickly installation, right? So you can share your screen. Okay, I make you presenter. Yeah, this.
Are you able to see my screen? Okay.
Still not. Yeah, yeah. Now it's coming. Okay. Can you go to your VM?
Yeah.
So you install Ubuntu also. There is a step. Okay, Ubuntu. Okay. Oh, sorry. Chrome browser. Okay, so that will be. Cases are not used. So, and one thing is we have to add a terminal, right? Because every time we will use a terminal, so we'll add the favorite.
Yeah.
And did you enable the copy paste, right? The bidirectional? Because in the virtual box now there is a setting, so there we can set. Okay, I will tell that one, right? So you don't need to copy anything from the Windows to virtual box. So you don't need to like it can be bidirectional, so you can copy paste easily.
Okay. Actually, I'm not sure, Arvind.
Okay, and where the virtual box is there, can you go to your virtual box? Where the
Yeah,
virtual,
sure.
yeah, here. Second. Yeah, I'm not getting access on the, I think your Mac machine. Okay, do this. I think it is because of the security access. So just click on the settings. And go to the system. I think advanced here, advanced. General, yeah, advanced. And here is the enable this one bi-directional board. Can you copy some text here? This Ubuntu VM, just copy it.
Okay, from MacBook, right?
Mac. Just anything you copy, just any word.
Okay.
No, not like this file. I'm saying some text, just any text you copy. Any rename you do, just text you take it.
Okay, got it. Okay.
And go to your Ubuntu and open the terminal, click on the terminal. Paste here also in the browser. It is copy pasting or not.
Okay.
It's not coming. Okay,
No, I'll just try one second.
it should work right, but maybe Mac, I don't know.
No,
I'll
not
check.
that. Just
Huh?
go to your notepad and type something and then copy it and paste it.
Okay, do that.
Okay.
Go to notes.
Yeah, for me it works for copying pasting into like Notepad, but then not on the terminal. For terminal, it doesn't seem to. Maybe.
No, you are able to copy paste like
Yeah.
copy paste will find, right?
Yeah, I think copy paste register works.
Actually, Mac, it's a problem with the Mac, okay, because Mac is not providing because of security, okay, because Mac is not easily provided. Okay, I'll tell
Okay.
about that. Okay. So
Sure,
we
sure.
have- because this Ubuntu VirtualBox you are running in Mac means it could be give any issue, right? Because we are not sure. Okay, because it's not compatible, first of all. Okay, install. So first thing is we need Java. Okay. So Java 1.8. We do the sudo apt update. So this will update the repositories. Any package, anything missing. So that will be done. This is general commands, not Hadoop. It's a general. Can you enter password? Install Java. Go open JDK. I think the speed is not that much faster. How much RAM you given for this VirtualBox?
I gave almost 6 GB RAM, Arvind.
6 GB and 8 GB total you have?
Yeah. Yes. So today we have issue with our internet, so I'm using it with my mobile hotspot. Maybe
That
that's
could
the
be.
reason. Yeah.
I have one quick question.
Mm.
I'm trying to do the same steps, and when I put the password after I do the sudo apt update, it says
No
it says my
sudo.
use
No
no sudo on file.
Okay, so you didn't get this problem, Satya, because you also
No,
installed.
no, Armin. No, Armin.
Okay. You
It
are
asked
also
me
using
to
the-
change the username multiple times, but no issue
Okay, for
regarding password.
that, actually you have to add your user in the sudo file. So you go to su minus, you go to the root first, and vi sudo you open, vi sudo file. Okay. I show here, okay, so that you can see, because
Yeah, I'll try.
some I don't know why it didn't come here, but whenever who is installing the Ubuntu 22 version and VirtualBox 7, so they are getting this issue. So you cannot run any command without adding your user as a sudo user. Okay, so
Okay.
that will be issue. If you see my document is there, right? In my document there, I mentioned this thing, like how to add
Okay.
the VI sudo.
I'll
So
look at
you have
I'll look at it then.
su minus, then
Yes,
you
I
will
did that
have to
part. Yeah.
go to root. Mhm.
Yeah, I did su minus, and it just says command su minus not found. Did you mean? And then it gives me try
For authentication.
apt install.
Okay, so how to go to the root? Sudo. I came to the root. Okay, here I will type vi sudo. So here you will see there is a root user is there. So here if you do entry, so better you do also entry. So that is good because no other. Yeah.
Mm.
So here root. So here, yeah. Yeah. Can you add the entry here? Your username. What is your username?
I
From
mean, yeah,
You can write your username, right, which you use, right? Yeah, you created login. No, this is Ubuntu only. Okay. Mhm. So as it is, you give, right? Whatever capital is small.
okay. This is the username.
Okay. And then same thing we have to do. Yes. So, right here. So you do also the same thing, and then you save it, Control X, Shift Y, Enter. Okay. Control X, Shift Y, Enter, and then you exit. Then after you can run any command. So we installed the Java, the Java hyphen version. Verify the Java version. So Java is installed. And here in this document you see, okay, so here is we have to install this OpenSSH server and client. This is for passwordless authentication purpose. So this step we don't need to do, create Hadoop user, because we will be doing everything in our user, okay? All the Hadoop ecosystem component. So if we create our additional user, right, add user, so it will give the trouble for the other Hadoop ecosystem component. So this part we have to skip, this complete create Hadoop user, we have to skip, okay? Next thing is we have to use the passwordless SSH keygen. This is public private key, right? We use, right, to authentication purpose. So this is not related to Hadoop. This is general, right? We do, because Hadoop having the 5 services, right? So if you are not doing this passwordless authentication, what will happen? Every time it will ask password of your machine, right? Starting the services. Okay. This. And next is copy the public key into authorized key. So you have seen this type of thing in the when GitHub, right? We are using, right? And I want to do the public private key authentication, right? So we create a key gen, and whichever machine you are committing your code, right? So it will store one public private key, right? So that will be you don't need to enter the password again, right? While you are checking code in the repository. Okay, so this is we are giving 600 permission to the authorized key. Now this is the Hadoop we are downloading. So this is official Hadoop page, and here is a 3.3.6 version. So we have to click on the binary. So we need to download the binary zip, and we can use wget command also, or we can use directly download this, and then we will keep it in the software folder. So this step, once you download this, so this is the same thing what I, or we can directly use the wget command wherever we need to download, or we have to tap. But if you get in the download folder, you can right click and extract. So you will get the Hadoop folder, right, after extracting. So once you get the extracted folder, so we have to create one software folder in our home directory. Here, software folder, the softwares folder. So we will keep it all softwares here, so that we will have the location, right? So
So after downloading the software, we need to give the specific location.
so this, okay, I show the, okay. So main, how much time? So this one is basically the configuration file setting, right? Once your this Hadoop is downloaded, okay, so you have to extract it, copy, you have to keep it in this software, okay, and then we have to set configuration file. So first is the bash rc file. So this bash rc file you will get here in the terminal here. So you can nano .bashrc. Okay. So when you open this file, this is the environment file where you have to set your home path. So in the Ubuntu, we use this file to set your Java home, Hadoop home, Spark, Kafka, any home path. So you can start from anywhere. You don't need to go to the bin directory and start, right? So that's the purpose of setting the home path. So in this bash rc, you will be setting this entire copy this entire path, okay? But here you have to change the directory and the software, because you captured your Hadoop in the software, right? And change the version because I'm using 3.3.6. So you change this version, okay? So this line you have to change. And here is a one equal sign will come, Hadoop _ opts equal, okay? So here equal will come. If you see my instruction, I have mentioned, okay? And next file is this is after this you have to do this source command. If you don't use source, so your installation will be not applied. That means like your path is not applied, your this home path, okay? So you have to use every time whenever you change in the bash rc, you have to run the source command. So if you are anywhere other location, you have to use /.bash rc. But if you are directly in the home directory, you don't need to give /, okay? So how to come out from this? Control X, Shift Y, Enter from the Nano editor. Okay. So Nano editor or VI editor, you can use anyone. So Nano editor, you save the file, you use Control X, Shift Y, Enter. If you don't want to save the file, Control X, Shift and Enter like that. Okay. So this path I can copy because we know our version and everything, right? So we can make it copy this path. So we can I don't know. First change you have to do here, equal sign.
So instead of Hadoop, we need to give the software location and Hadoop
But before
software.
that, you have to give your user directory, because this Hadoop is their user, right? They created separately, right? But we are not using the Hadoop user. So you give your
Okay.
Dash your user.
So should I give my username here?
Yeah, user directory, yeah.
Okay.
Yeah, slash softwares slash just change the version. Hadoop 3.3.6. We are doing 3.3.6. Yeah. Now do Control X.
Okay.
Use your
I guess I
Mac.
need to change it.
Hmm.
Okay.
Shift Y.
Shift Y.
You use your Mac one, right? Because okay, if I do in my case, so I will do Control X. Okay. Like Control X, it will ask like Y or N. Then I will do Shift Y and then press Enter. Okay, then I will come out.
Okay.
I did from the Windows. Okay, and then we have to
Okay.
do source DASX. Once this done, but other we have to wait. I think your solution.
Yeah, it's too
Let me
slow.
show the steps. So once okay, so this my installation document is there. So here you want to install okay, so here like once we downloaded right this Hadoop, right? Then we have to copy into the softwares. Okay, so one file we have to modify, this Hadoop env.sh is there. So you will find this file in the location etc Hadoop. So your software Hadoop, your Hadoop version, because your version is 3.3.6 and etc Hadoop. So you will get all these files there. Okay, so Hadoop env.sh one file is there. So you have to add your Java home path as it is, you copy paste in somewhere in the Hadoop env.sh and save it. Core site.xml, you add this configuration, right? Copy this configuration, you can copy. Okay, and our same thing is there in the website here because I copied from the website. Okay, so for core site, This is a high one. So for core site, if you see so core site, we have this configuration, right? So we have to go to the core site.xml file and copy paste the configuration to configuration tag. So there is an empty configuration tag, but you have to replace configuration to configuration and change this user. Okay, here you have to change the user, your user. Okay.
Okay.
Next one is SDFS site.xml. So SDFS site.xml, again, you copy this entire configuration. Okay, here is the replication factor is there. So I was talking about the replication factor is 3, but it is configurable. Like you want to make a 1 copy or 2 copy or 3 copy, because same node, same machine you are installing. So there is no point to mention 3, right? Because it's the same machine, right? So it is basically 3 is used for the cluster, right? Any cluster environment where the multiple nodes are there. For single node machine, 1 is good, okay? And here you have to change your user again. So /home, like your username, that's it. These 2 places you have to change. So this is the only 2 changes. 1 change is here in the core site, and 2 changes are here in the SDFS site. And after that, next file is a mapred site.xml. So this just as it is, you copy paste whatever is given here. Next is yarn site. This is the last one. So just copy paste this entire one in the yarn site. Okay. Once after done this all, you have to run this command, SDFS name node format. So when you run this command, your name node will format like as a empty, like your Hadoop file system. Okay. And then you start -all.sh, or 2 commands are there, separate command for the storage service or processing service. So for storage service, the separate command is start dfs.sh or start yarn.sh for the resource manager and node manager. If you don't want to use separate command, one single command is there, start -all.sh, that is given in my document. So if you see here, this is all configuration. Once you done this SDFS name node format, then you type this start all.sh, and then you see the JPS. So you will see these 5 all services running. Okay, and then you can see the Hadoop fs -ls/ it will show your Hadoop file system, but it will be empty. So what you need to do after that, you have to create a directory and you have to create a copy of file that you have. Okay, so this is all installation of the Hadoop. So first step is like you have to download your Hadoop, and then you have to change this configuration file. So if download is faster, I'm saying it's a 10-minute installation. It's nothing more than that. If everything just you copy paste, then your Hadoop will be running in the 10 minutes. Okay. Okay. If anybody gets a problem, I can see tomorrow. Okay. I believe, right, it's a very straightforward, like if someone runs, right, I think it is a easy steps, right, to configure. Okay. So show me tomorrow, Satya, if any issue is there. Okay. I'll check it.
Sure, Arvind.
And this document is there in the classroom. Okay. This, and today one, I will upload it in the same classroom here. I will add it here. The training right here in the classroom. Okay. Yeah.
Okay.
Okay. Thanks everyone for attending session. Thank you.
Thank you
Yeah,
so much.
Thank you.
Thank you.
thanks, Arvind.